Okay, section 5.1. This whole chapter we're going to be dealing with triangles, okay? And the first two lessons, 5.1 and 5.2, they're I don't know if I'd say they're real hard or real difficult, but sometimes it's difficult to keep the things straight. We're going to talk about two major things today, and then when we do 5.2, we're going to talk about two major things on 5.2, okay? So there's two things we're going to learn today, and they all have to do with triangles. But before we get into the triangles, we need to talk about this. And we might have mentioned this in the past. I'm not really sure if we did or not, but I'll do it here anyway. Let's make that a little thicker. Okay, so here's a line segment right here. It's not just a line. It has a start and a stop. So we'll put an endpoint on one end, endpoint on the other one. We'll call this A, and we'll call this B. So what I'm going to do, and what we're going to do with a triangle in here in just a couple minutes, is we're gonna have to write the perpendicular bisector. So jot that down. Perpendicular, and you know what both of these things words mean. Just not sure if you had put them together yet. Perpendicular. There you go. Perpendicular bisector. Well, when you see that first word, perpendicular, what do you think of when you think of perpendicular? Two lines that are what? Well, they're perpendicular. If two lines, if they're perpendicular, they make what? They form what? A 90-degree angle, okay? Everybody understand that, right? So they form a right angle. So what I'm going to do is I'm going to have another line here. I'll just use another color. And I want to make it perpendicular to this, all right? So those two lines look perpendicular, don't they? Now, they're only perpendicular if you do what, though? Put that little box thing, right? Okay. Remember we had a whole thing on that? Remember I gave you a triangle. I said find the distance between this point and another line, and it had to be perpendicular, and I made a big deal about putting the perpendicular sign, right? That right angle box. Anybody remember that? Yeah, just had it on a test, I think. So you know what perpendicular is, but there's more to just being perpendicular to this thing right here. There's two parts to this. So that's the perpendicular part. We understand if it's perpendicular, they make a right angle. What about the bisector part? What do we do when we bisect something? In this case, we're bisecting a line segment. What am I doing if I bisect it? Do I just go through it? Do I just intersect? I need your help, okay? You guys are way too quiet. I need you to talk. Okay, split it in half. Exactly right. So if you take a look at this thing right here, look at this line segment. Two things are going to happen to this line segment. I'm going to split this line segment in half into two equal parts, but I'm also going to draw a line that's perpendicular to it, and it splits it into two equal parts. So what do you think that's going to look like? Well, first of all, let's do this. Let's put a little dot there where the midpoint's going to be. All right. Let's go back to blue again. And now what I'm going to do is I'm going to put a perpendicular line. Do I just put the perpendicular line right there? Is that a perpendicular bisector? No. What if I put it like way over here on the end? Is that a perpendicular bisector? No. Where do I have to put it? In the middle, at the midpoint. It's got to go through the midpoint, correct? Right there. So if I put a little right angle symbol and it goes through the midpoint, what is this blue line right here? Then it's a what? Perpendicular bisector, isn't it? All right. So both of those things have to be true. Perpendicular, it's got to make a right angle. It's not the greatest right angle symbol there, but you get the idea. Let's make it look a little bit better. There we go. So you put the little box there to mean it's perpendicular, makes a right angle, and it has to be a bisector. A bisector. What's the prefix bi mean? B-I. Two. Right. Like bicycle, right? You ride a bicycle. It's got two wheels. So it splits into two equal parts. So we'll call this C right here. So what do we know about these two segments then? AC must equal what? CB or BC, right? Okay, so those two have to equal each other if that's the midpoint. So this blue line right here would be called a perpendicular bisector. So we have to know this before we deal with a triangle. Remember I said this whole chapter is about triangles? We haven't even dealt with a triangle yet, have we? But we're going to do this with a triangle here in a second. Is everybody okay with that? All right, so if I take a line segment and I want to find the perpendicular bisector, that's what I do. You could also, I mean, the segment doesn't have to be like horizontal like that. Okay, it could be like this. Oops. Here we go. Look at this thing right here. What if this was my line segment? What if this was like line segment EF right there? What if that was line segment EF? and I told you to draw a perpendicular bisector to that segment. Well, first of all, what would you have to do? Find the midpoint. That's right. So if I, on this program, this little box shows up. So if I line those two dots up right there, that would be my midpoint right there. And if I want to draw the perpendicular bisector, then I got to start at that midpoint, right? And go up and make it look like it's perpendicular. That looks about perpendicular, doesn't it? Now you could stop it on the midpoint if you wanted to, or it could keep on going through if you wanted it to. It doesn't matter, all right? As long as it hits the midpoint and it's a right angle. So that would also be a perpendicular bisector. So a perpendicular bisector doesn't always have to be straight up and down like this. Everybody see that? It all depends on the line segment. So now let's see what we're going to use this for. That was all leading up to this. All right, let's make this real big because I'm going to draw all over this thing. So I'll give myself some room. All right, so what we're going to do now is we're going to actually draw 3 perpendicular bisectors in this triangle. So I'm going to draw 3. Now watch, I'm going to put the symbol for perpendicular so I don't have to write that whole word out. I'm going to put 3 perpendicular bisectors on this triangle right here. Everybody with me? So first thing we're going to do, I'll tell you what, let's label this. Let's label it ABC. Okay, let's take a look at the bottom first. This is probably the easier one. Okay, CB. If I want to draw the perpendicular bisector, and let's just do it in blue like we did before. Stay color coordinated here. So I want to draw 3 perpendicular bisectors. Well, I got 3 sides, don't I? So I can draw 3 perpendicular bisectors to the sides. So let's take this bottom side right here, CB. Well, first thing, what's the first thing I need to find in order to draw the perpendicular bisector? The midpoint, that's right. So I click on here where those dots are, that's the midpoint, so I'll put a little dot right there. All right, let's go back to blue. And now, if I want to find a perpendicular bisector, what do? I start at that midpoint, and how do I draw it? What is it? Perpendicular, right, exactly. Okay. Now you could go up through the triangle if you wanted to. You could stop on the triangle. Okay. It doesn't matter. Let's just go through the triangle like that. Now, it's perpendicular, so we put our little right angle symbol. Look, those 2 segments are equal to each other because that's the midpoint. So that's a perpendicular bisector. Right? So that's the 3rd time today we've done a perpendicular bisector. It's the first one on this triangle, but we did 2 earlier, didn't we? See, there's 1 and then there's 2. So this is the 3rd one we've done. So you should be kind of getting used to this now. Now what are we going to do? Go to one of the other sides and do the perpendicular bisector of one of the other sides, because I'm going to draw 3 perpendicular bisectors. So let's go to this side right here, AC. So what am I going to have to find first? The midpoint. So right there looks like it's the midpoint. And I want to draw a perpendicular bisector. Now since I got this cool program, I can do this. Watch. I'm going to copy and paste, and I can rotate it so that it's 90 degrees. And now I know it's exactly perpendicular to that line. Right? Now I know you can't do that on your own paper. You're just going to have to eyeball it and draw it, but I can do it on here. All right, so what am I going to do? I'm going to go to that midpoint and put that there, and this, we'll just extend that out a little bit further. So now look at it. It's not just perpendicular. Where did we make that perpendicular line hit? Right at the midpoint. So what is this line right here? It's a perpendicular bisector. Getting the hang of it now? Now we got to do one more. Where's the other one? What line segment are we going to use? AB. Good. So let's do this. Let's copy and paste it. We'll rotate it 90 degrees right there, and we'll make a blue just so we stay coordinated here. And I'm going to take this and I'm going to move it around. Oh, you know what I forgot to do? What did I forget to do with AB? Forgot to find where? The midpoint. So I'd say it's about right in there, wouldn't you? About right there. And let's connect it. About right there. Now check this out. there's 3 perpendicular bisectors. And you say, well, big deal, who cares? So you got 3 perpendicular bisectors. But they actually do something here, don't they? They actually do something that's kind of interesting. Do you see something? All 3 of those lines do what? They intersect, right? All 3 of them intersect. All right, and that's kind of unusual for 3 lines to intersect. Sometimes, I mean, you can always take 2 lines and they can intersect, but to get to all 3 intersect in the same point, okay, that's a little bit special. Tell you what, just to make this look a little bit better, I'm going to go about right there. Okay, so they all intersect at that point right there. Well, that point has a couple names. We're going to do some vocab here. Anytime you have 3 or more points that intersect each other at the same point, we call them concurrent lines. Write that down. Concurrent lines. Good, thank you. So concurrent lines. So if you have 3 lines that intersect each other at the same point, you may want to jot that down. 3 lines, 3 or more lines. You could have 4 or 5 or 6 if you wanted to, but we're only doing 3 right here. If you have 3 lines that intersect in the same point, then they're called concurrent lines. This point right here, we'll call it P for point. That's called the point of concurrency. And I'll use these words periodically. I'm not going to like test you and say write down the definition of point of concurrency, but you need to know what I'm talking about if I do mention them. So this is in general, okay? This is just in general. Any 3 lines, 3 or more lines that intersect in the same point is called concurrent lines. That point itself, where it intersects, is called the point of concurrency. But now we're going to get a little bit more specific. Let's do this in yellow. So this point right here that's formed by 3 perpendicular bisectors is called the circumcenter. All right, and that is important to know. That's very important to know. So what is the circumcenter? It's the point that's formed by 3 perpendicular bisectors on a triangle. Everybody hear what I said? So it's the point. The circumcenter is that actual point right there, point P. And how did we get that point? What did we draw? We drew 3 what? Perpendicular bisectors, didn't we? So if I take any triangle and I draw 3 perpendicular bisectors, they're always, it's not just specific to this triangle. It could be any triangle at all. It could be this is an acute triangle. It could be a right triangle. It could be an obtuse triangle. Any type of triangle. If I draw 3 perpendicular bisectors to the sides, it's always going to hit at one point, and that point is called the circumcenter. Now, why do they give it a fancy name? Well, because there's something that's kind of interesting about this circumcenter. Watch this. I'm going to keep this in yellow. What if I go from the circumcenter? Remember, the circumcenter is the name of a point. So if I go from this point, let's go to C. All right, so I've got a yellow line right there. Say, why did I draw that? Well, because I want to do something else. Watch this. Let's go from that circumcenter again. If I went to point C, where do you think I'm going to go now? Point B. And if I went to C and B, where do you think I'm going to go now? Go to A. Now, there's something special about these 3 lines right here that I just drew. What do you think, just off the top of your head, just looking at it, what do you think might be true about those 3 yellow lines? They're going to be the same, exactly right. And they are. That's what's special about this circumcenter. All right, so this point right here, this point of intersection between the 3 perpendicular bisectors, that's a very special point because that point right there is the same distance from all 3 vertices. That's the circumcenter. Everybody see it? So let's write that down. It's the same distance from all 3 vertices. You know what vertices are, right? It's just the plural of a vertex. So A, B, and C. So that point right there is the same exact distance. So if I want to, I could say that AP equals CP, which equals BP. You kind of know what they're going to do here on the questions they're going to give you, don't you? I mean, like if they said this, what if they said this AP is 5 and they ask for CP? What would CP be equal to? It'd be 5, right? All right, it wasn't hard to do. You just had to know that the circumcenter was equidistant from the vertices. Okay, equidistance means the same distance. All right, it's just a fancier word, equidistant. So if this is 5, CP is 5. Well, what's BP equal to then? 5. Now, they're probably not going to make it that easy. They'll probably do something like this. I'm just making this up off the top of my head. What if they did this? Let's say AP was 3x plus 1, and BP was, I don't know, 2x minus 3, or something like that. Yeah, exactly. You would set them equal to each other, and then you could solve for x, couldn't you? And then you could actually find the length of it too, couldn't you? All right, because you could find x, chuck it back in for x right here, and then figure out how long. Now, all three of these should be the same distance, though, shouldn't they? Does that make sense to you? So that's the kind of stuff they're going to do on these problems. All right, they'll say, okay, this is the circumcenter. All right, and then they'll say this is 3x plus 1, 2x minus 3, solve for x. Or they'll say, what is the length of AP? Right, so you solve for x, plug it back in, and you solve for AP. We good with this? So what did we do to find the circumcenter? What did we draw on our triangle to find the circumcenter? We drew what? It's right there in front of you. 3 perpendicular bisectors, that's right. Okay, and now you know how to do a perpendicular bisector, right? You take the midpoint of one of the sides and you draw a perpendicular line to that midpoint. You do that for all 3 of them, and if you do it right and you're very, very careful with it, then it's going to all meet at one point. Now, if you're real sloppy, they may not meet, okay? But if you're very careful about it, make sure it's perpendicular, make sure it's right on the midpoint. If you do that, then it's going to hit right at one point. And that point is equidistant. It's the same distance from all 3 of the vertices. We good? All right. So we're going to do 2 major things today. That's the first one. Okay, that is circumcenter right here. Okay, now what we're going to do is another one. Let's get that. Okay, we'll copy that triangle. I'm going to use the same looking triangle. Again, you could do this with obtuse triangles, with right triangles, but this is pretty easy to use this nice acute triangle. So I'll just use this. So now what we're going to do is another type. Stay with the same color system here. This time, what we're going to do is we're going to not do perpendicular bisectors, but we're going to draw 3 angle bisectors. So we're not splitting the sides at the midpoint, are we? And let's do this. Let's call it ABC, just like we did the other one. But this time, what are we going to do? We're going to bisect the angles. So what does that mean we do if we bisect an angle? We split this angle into what? Into 2 equal angles. That's right, 2 equal angles. Now, with this program, I can't really tell which, what's halfway between this angle, so we'll just have to eyeball a little bit, okay? Now, what if I did that? Would that is that bisecting that angle? Nah, because that angle on the left is way smaller than the one on the right. Now, if I went over there, it's completely the opposite, isn't it? So tell me when. Now, look, I'm not looking at CB, and I'm not trying to find a midpoint of CB. It's not what I'm doing. Okay, I'm looking up here. Everybody see that? I'm looking up here at this angle, and I'm trying to find a line, a ray, that's going to split this angle into 2 equal angles. So we just have to eyeball it. So what do you think? Maybe about right there? Maybe, yeah, it looks pretty close, about right there, don't you think? Okay. And you could keep on going all the way through that triangle if you wanted to. You don't have to stop here. All right, I just happen to. Let's do B next. What if I do B? Am I going to go way up here like this? Way down here like this? No, I'm going to try. Now again, where am I looking? I'm looking right here, aren't I? I'm trying to find out where I split this angle into 2 equal angles. And maybe about right in there. Does that look about right? Yeah. I don't know, maybe up a little further. I was probably pretty close earlier. So what have I just done? Up here, I split this angle into 2 equal angles. Down here, I split this angle into 2 equal angles. So what am I going to do now? Do the same thing with the other one, right? Exactly. So let's take point C and split it. And guess what happens? Well, it's not a circumcenter, because the circumcenter was found by doing 3 perpendicular bisectors. We can say that the 3 lines are what? Talk to me. concurrent lines. What does that mean? It means three lines that intersect at one point. Okay, so they are concurrent, but they're not the circumcenter. Remember, the circumcenter is found by doing three perpendicular bisectors. So this is a different name, right? They all intersect each other, which is kind of nice. Okay, they're concurrent. That's the point of concurrency, but now we have a different name. Instead of calling it the circumcenter, we call it the incenter. I wish I had a nice, easy way to keep the two, not confused, so you know which one goes with the circumcenter, which one goes with the incenter. But I really haven't been able to come up with a cool little way to remember it. You're just going to have to remember it. Okay, let's go back here again. So how do you find the circumcenter? You draw what? Three what? Perpendicular bisectors. Okay, that means you take the side, you split it at the midpoint, you do a perpendicular line. This is completely different, isn't it? Now, we still are splitting something into two, but what are we splitting into two? Not the side, but the what? But the angle. That's right. We're splitting the angle into two here, aren't we? All right. Oops. Let's show that right here. So that angle is equal to that angle. Now, look, just because it splits the angle in half, does it mean it hits it at the midpoint? Does that look like it's at the midpoint right there? Not really. The midpoint would probably be way over here somewhere. Okay, the other two kind of look close, but it's not going to be. All right, it doesn't have to be. All right, so if I split this angle in half, that doesn't mean it's going to hit the midpoint of the opposite side. A lot of people think that's true, but it's not necessarily. Okay, so we have an incenter right here. Well, there was something special about the circumcenter, so guess what? There's something special what? About the incenter, that's right. So let's figure out what is special about the incenter. Well, let's start at the incenter. Now, the other one, it was equidistant from the vertices. What do you think about this one? Do you think it's the same distance? Do you think the incenter is the same distance from all three vertices? Look at the three yellow lines I just drew. Does this line look equal to this line right here? No, not at all. Okay. This line doesn't look the same as this line. Now, these two may look a little bit close to each other, but they're not necessarily equal to each other. So that's not true. That's only true on the circumcenter. But what's true about this? Well, I'm glad you asked, because I'm going to tell you. Watch. So that incenter right there is equidistant, not from the vertices, but from the sides of the triangle. Okay, so what is the distance from a point to a line segment? It's a perpendicular distance, isn't it? So what if I drew the distance from this incenter to this triangle? That looks perpendicular right there. And then let's draw from here. Now that kind of looks already perpendicular, but let's make it not quite hit. Do you see those three yellow lines right there? On the circumcenter, what were the yellow lines? The yellow lines were the same distance from the vertices, right? But this time, the yellow lines are what? The same distance from the sides, not the angles. Okay, this goes to the side, this goes to the side, and this yellow one goes to the side. Everybody see it? So those three lines right there are exactly the same. So I could put a little tick mark here, here, and here. All right? Courtney, you getting all this? You writing it down? I see a lot of people taking notes, which is good. I see a couple of you not taking notes, which is not so good. All right? So I'm going to get rid of these tick marks here. Remember, the yellow ones are all equal to each other. So what could they do? They could say, oh, that side is 3, so what's the length of this one right here? Well, you would say that was 3, wouldn't you? What if up here they said this angle was 20 degrees? What would this little angle right here be? That would be 20 degrees. What would the whole entire angle A be equal to? 40 degrees. You follow me? Okay, yep. You with me on that? Okay. Look what else. This is the distance from this point to this line, so it's a right angle, isn't it? So what kind of triangle do we have formed right here? Like this triangle right there that I shaded in. What kind of triangle is that? It's a right triangle, isn't it? All right, we know some stuff about right triangles. What's one fancy math word that we know that talks about the sides of a right triangle. I'll give you a little hint, because you're going to need this to do a couple problems. What if I call that A and I call that B? What would I call this one? C. What did we learn that we could find one of the missing sides? You should have learned in Algebra 1, and we have discussed it a little bit. We're going to discuss it a lot more in another chapter later on this year, but you should know what that is. If you have a right triangle and you got an A and a B and a C, come on, somebody. Yeah, what is that? It's the A squared plus B squared equals C squared. That's right. What is that thing called? Nobody remembers it? This is a huge deal in math. It starts with a P. Pythagorean Theorem. Very good. Okay, it's Pythagorean. Just popped into your head, didn't it? See? Alright, it's called the Pythagorean Theorem. So you might have to use that from time to time, because you do have right triangles in here, don't you? Alright, and you got lengths of sides that they're going to give you. So that could be very, very helpful. Don't forget that. Well, I shouldn't say don't forget it. You should learn it, okay, because it sounded like you did forget it already. But Pythagorean Theorem. We've done that in this class this year, haven't we? A little bit. Not a whole lot, but a little bit. Did you do it in Algebra 1 last year? Pythagorean Theorem? Yeah, you've seen that, haven't you? A squared plus B squared equals C squared? Yeah. All right. That's just a little hint, though, because you're going to be some problems where you're going to have to find the lengths of some sides, and Pythagorean Theorem is really going to help you out, because you do have a right triangle in here. All right. So let's review quickly here. Then if we have time, we'll do a quick example. So look at this triangle. What did we do with the blue? We did 3 perpendicular bisectors. So what did we do? We took one of the sides, we found the midpoint, and then we drew a right angle, a perpendicular line to that midpoint. So that's one perpendicular bisector. We did that with all 3 sides. Midpoint, perpendicular. We did it here. Midpoint, perpendicular. And they all just happen to do what? Intersect at one point, right? We call that concurrent lines. But what's special about this point that's formed by the perpendicular bisectors? We call it the circumcenter, right? That's specific to this right here, okay? So this is called the circumcenter. We find the circumcenter by finding the perpendicular bisectors. Now, what's special about that point right there? What's special about the circumcenter? It's what? It's not just in the middle. What do we say? It's equidistance, or it's what? The same distance from the 3 vertices, right? So this point right here is the same distance to C as it is to A as it is to B. And that's really, really helpful. Make sense? Okay, so you got to keep that straight. That's our number 1 triangle. Okay, we're going to do 4 of them all together. Today we're just doing 2 of them. All right, so that's the first one. The second one is this one right here. That's the incenter. Well, how did we find the incenter? How did we find that point right there? Okay, so we did what? We did angle, let's use the word, bisectors, right? We did angle bisectors of all 3 angles. All right, so we took this angle and we split that angle in half, didn't we? We did it here, we did it here. And they all meet at one point. So all 3 of those lines are concurrent. They meet at one point. And that point is called the incenter. Everybody got that? So we find the incenter by doing the angle bisectors. Now, what's special about the incenter? Well, the incenter, let's write it down. We didn't write it down. It's equidistant, or the same distance. Equidistant, all right? It's equidistant from the sides, okay, of the triangle. So it's equidistant. The incenter is the same distance. That's what right? Equidistance, equal distances. So it's the same distance from the sides of the triangle. So here's my incenter. So what's the distance from here to this side? It's the perpendicular distance. What's the distance from this incenter to this side, AB? The perpendicular distance. Same thing with AC. That's why I drew the perpendicular symbols there. Does that make sense? All right. And what's true about all 3 of those? all three of those yellow lines right there are equal to each other. That's really, really helpful. We got a couple minutes here. Let's do an example, okay? Let me find a good one. Alright, here's one. I'll just try to draw it so it kind of looks like the one in the book. Kind of looks like that, that, and that. Let's just make it white. And we'll draw the stuff in different colors. Alright? And what they say, now you got to be careful with this one. It says P is the incenter. There's going to be a point in here somewhere. I haven't drawn it yet. There's going to be a point in here that's the incenter. How do you find the incenter of a triangle? What do you draw to find the incenter? Bisect the angles. That's right. Okay, so let's do this kind of quick. All right, we're going to bisect the angles. So if I take this and I bisect it, help me out a little bit. Look at it. Where do you think? About right there? That's pretty close. If we bisect this angle, I wish I had a little thing on here where I knew exactly what bisecting angle was. Do you think that's about it? About right there? That looks kind of like I bisected it. Does it? It's a little too much. It's too high. So maybe about like that. Is that better? Okay. And then bisect this. Now if I bisect it correctly, what should it do? It should go right through here, and that's your incenter, isn't it? Everybody see that? So that's your incenter. I'll tell you what they do though. Watch this. On this picture, they don't draw this all the way to the other side. Guess where they take it? They just take it to the incenter. Okay? So they go from the angle just to that point when they're drawing this. Okay? So right there, if I've bisected these angles, okay, that's the incenter. This is point P, and it says that point P is the incenter. So what does that tell you? Without them even telling you, if P is the incenter, what does that tell you about this angle and this angle? They're equal, right? Because you did what to get the incenter? You bisected, didn't you? All right. Everybody with me? Now, let's do this. Let's do this in another color. What's true about the incenter then? It's equidistant from the three sides. So where am I going to draw this? Do I go to the midpoint? No. I draw it so it looks what? Perpendicular. Okay? So that right there should equal that right there. That looks perpendicular, doesn't it? Pretty close. And that looks about right there. So do you see those three yellow ones? They might not be perfect, but you get the general idea, right? Those three yellow ones have to be equal to each other. Now let's see what they give you here. They tell you that that segment is 12. They tell you that this blue one right here is 20. They tell you that this is 31 degrees. And they tell you that this is 27 degrees. Alright, and they put some points in here. We've got X, Y, and Z for the triangle. And you got some L, P, and J. So that's L, there's P already, and that's J. So here's the question. The question says, find PK. Find the length of PK equals question mark. Oh, forgot the K. It's right there. Alright, so we got to find what PK is. This little bit from here to here. Well, remember what's true about PK. PK is also equal to what else? PL and what else? PJ. Everybody see it? So all three of those yellow ones are equal to each other. So they say to find PK, but look where they give you all the numbers. They give you the numbers down here, don't they? So watch this. This is 20. This is 12. So if I find PJ, isn't that going to be exactly the same as PK? All right, so let's find PJ instead, and let's just call it X. Is that all right? What kind of a triangle do I have here? I gave you a big hint when we went over this earlier. It's a right triangle. And look what I have. I've got one side of the right triangle. I got another side of the right triangle. How do I find the third side? By what? Pythagorean Theorem. Right, exactly. That's why I did all that. Everybody see that? Tell you what, let's draw it just a little bit nicer. And I'll kind of twist it so it kind of looks like this, doesn't it? This is the 12. This is the 20. This is the x. Now, how do I use Pythagorean Theorem to solve for x? Remember, it's a squared plus b squared equals c squared? Well, what's the a and the b? The a and the b are the two legs. So I would write it how? X squared plus 12 squared equals 20 squared. And then we do our math. Here's the math. 12 squared is 144. 20 squared is 400. Subtract 144 from both sides. You can actually do all this on your calculator if you really wanted to. And this is what? 254. Did I do that right? I think. And then, do I have a calculator here? Is it 254? Did I do the math right? Square root. Let's see. I shouldn't use this calculator. I can barely see the. Okay. Square root of 254. Yeah, I didn't think I did that right. I think it's 256. Yeah, I can't do my math. What did I say 4? Thank you. It's 256. Okay, so it's the square root of 256. There we go, and it's 16. Works out perfect. So x is 16, and that's what this is right there. It's 16. And that's what they ask you to solve for. Okay, so pj would be 16, so what's pk then? That would be 16 as well, wouldn't it? I know I went a little quick on that. Go back on the YouTube and watch it. Just go back to that part. See if you can do that. Let's do one more. Let's do angle LZ. Oh, ran out of time. Angle LZP. Try that at home. Or we can just do it right now. LZP. Which one is that? LZP. It's this angle right there. How do we figure out how many degrees that is? Well, it takes a little bit more effort. Watch. That's 31. That's 31. That's 27. That's 27. Add them up. Take them away from 180. Right? Divide it by 2, and you got that angle right there. Let me give you a worksheet. Whoever left, you need to tell them they need to get a worksheet.